to another episode of Let's Talk Exascale. For the Exascale Computing Project, I'm Mike Bernhardt. And for this update, we're here again today with ECP Director Doug Kothe. Doug, once again, thanks for joining us.
It's great to be here, Mike. Thanks.
Absolutely. So, Doug, now that plans for the first Exascale systems have been formally and officially announced, Aurora at Argonne and Frontier at Oak Ridge, and we know that the El Capitan system at Lawrence Livermore is right around the corner.
Right.
In fact, by the time this video gets out for most folks, it may have been announced.
Right. Right.
The announcement of the nation's first Exascale systems is such a huge milestone for this country and for the Department of Energy. What do we do to ensure that we will have a capable Exascale ecosystem, the software stack and the Exascale ready applications when these systems are actually standing up?
Well, good question. As we've talked in the past, Mike, the ECP team and the staff, we knew enough to where, in terms of what we think's coming, to where we weren't shooting in the dark, so to speak, with regard to building our software stack and our apps. But now with these announcements coming out, we have a more refined, focused target, and for the most part, it's not surprising. It's met our expectations, and I feel like our preparations have us on a good path. I do believe that both architectures, as we know of them, Aurora at Argonne and Frontier at Oak Ridge, are very exciting, have tremendous upsides, are consistent with our overall preparations, meaning the nodes feature what we call accelerators, which is hardware acceleration of certain floating point operations. So allows us to exploit those accelerators for our good. So overall, we're really excited. Sort of 3 years in, we have very specific targets now. They're not off in the ditch, so to speak. They really are met with our expectations, and from what we can tell in terms of the speeds and feeds and the overall design, they really do look very solid, very exciting, and I'm very confident we're going to be able to deliver on those systems.
And as you just mentioned, we're into our third year with the project. If you think back 3 years ago, where you thought the project would be at this point in time, are we on track? Have there been any surprises that have come across that have changed that schedule in your vision?
First of all, we are on track. There are always surprises in R&D, and many of them are good. Some, are I would say, setbacks or things you have to really prepare for. So relative to 3 years ago, we have teams now that have really figured out and fit well into our project structure. We have defined very specific metrics that are quantitative, but also directly reflect the overall goals and objectives, and in particular the science and engineering and national security objectives. We're able to, I think as of last year and now, I think we're really seeing this, have a really good sense of how we track performance. Are we on track? So when we say that, it's not really just a subjective answer. We really have a lot of objective evidence for being on track. And being a formal project, having very specific metrics helps us to make collective decisions about what matters, what doesn't, and it's all about achieving our objectives, which we've mapped into these specific metrics. So yeah, we're definitely on track. That doesn't mean that it's not going to be challenging, tough road ahead. I think we understand what the risks are, and certainly with Aurora and Frontier being announced, many of the unknown unknowns become known unknowns. And so I think we're even better prepared moving forward.
And so you mentioned that it's not just simply a subjective view of whether or not we're on track. So I understand that the team just went through something called a red team review.
Right.
Could you explain for our followers, what's a red team review and what's the significance and the impact to the project?
Yeah, and so red team many years ago, for me 30 plus years ago in the DOE was a new term. One could Google it and kind of see the historical aspects. I think it's a term that's readily used in business, in large organizations, in the military. For us, it has a very specific meaning that at a high level is not too dissimilar from other organizations and agencies, and that is we bring in a team that is there specifically to poke, to prod, to find any sort of flaw or hole in our plan. And the team is there to help us. They're not there to be punitive, but in other words, they're not friends and family, but yet they're there to help us and specifically find problems in our plan, in our objectives. So typically for us, we go through at least one formal review a year by our Department of Energy sponsors. And so what we do with the red team is 2 to 3 months before that formal review, we have a red team review. You could view it as an internal review where we essentially mimic the formal DOE review in terms of what we're going to do in terms of presentations and breakout sessions, et cetera, but with an external, independent, separate team with no conflict of interest with ECP, meaning folks working on ECP aren't a part of this. So it is very formal and very independent, and the red team, while not required from our Department of Energy sponsors, I think is expected to prepare. These reviews at times are painful, but because it requires a lot of work and a lot of sort of head-down focus. But in the end, they always help us in terms of finding areas where we need to do better, we can do better, implementing course corrections. So, in the end, at post-review, I think we all sit back and go, boy, that was painful, but we're glad we went through it because we're better off now. We have a better plan. We have corrective actions in place. So we did recently go through a red team review in preparation. Well, actually, a red team review and a design review. Our next big review with DOE is this December. And so we tend to not wait for the last minute to really be ready to show DOE that we're on a good path or on track, as you say.
Got it. So the red team reviews go a long way in helping instill confidence with you, the leadership team, and the program office, that your sponsors, that things are in fact on track, that you've identified the risk, you're taking all the mitigation steps, et cetera.
They do. I would say that the outcomes of a red team review are typically, hey, we recommend you consider doing this, this, and this, or fix this, this, and this. And so we call those formal recommendations. Typically we give ourselves 2 or 3 months to respond to those recommendations, to make those fixes. Obviously, if there is a systemic problem found by the red team that takes longer to fix, that's a problem for us. In the end, our red team reviews have been very successful, suggesting kind of minor tweaks, sort of realizing or relaying to us that we're for the most part on track. And so right now, we are actually making a few course corrections and a few changes in our plan as we prepare for our next DOE review, but I do feel like they're all necessary, needed, and probably the best news is they're consistent with our expectations as to where we needed to work. So we've not heard things that were sort of orthogonal to our own internal assessment. So having independent assessments is good, and it's even better when the results are consistent with our own view of kind of where we still need to put some work in.
Awesome. So Doug, I'd like to dive into one discussion just quickly here, and it's in reference to something we've heard recently at a number of conferences. Would it be accurate to say that accelerated computing and the implementation of GPUs is going to play a key role in delivering the necessary performance of our DOE exascale systems? And if that is the case, what's ECP doing to prepare the community for this?
Good question. It is accurate. I think we're going to see more and more of this, and maybe it's disingenuous to even call them GPUs because they're very purpose-fit hardware accelerators for specific floating point operations or specific operations that may not be floating point. And the way I like to think about it is in ECP, and this is an aspect of co-design, we're working on hardware-driven algorithm design, but we're also working on algorithm-driven hardware design. And so there is a give and take there. So, based on our experience with Summit and Sierra, Summit at Oak Ridge, Sierra at Lawrence Livermore, and the coming Perlmutter system, okay, and certainly Titan at Oak Ridge, we have seen and will continue to see hardware acceleration on the node. That doesn't mean it isn't easy. The point is we've been through this. I think we know what to expect. It is a tremendous potential for this sort of design. So there's a lot of concurrency, local concurrency, that we can exploit with an accelerator. So think now, I can now embody my simulation with richer physics, with broader, deeper physics, with higher confidence results, because I can afford now to offload some additional physics on the hardware acceleration. Or the current algorithms I have in place, if they don't adapt well to the accelerator, I've got to redesign and rethink my algorithms. And so we've been doing that, and the recent announcements of Aurora and Frontier will basically tell us that we're on a good path. I think with regard to acceleration moving into the future, I think my own opinion is we'll continue to see this post-exascale, and it could be even more purpose fit, more along the line of ASICs that are very specific to current algorithms. And again, I think what we're doing in ECP now is really hardware-driven algorithm design, meaning we know accelerators are here. We have figured out and are figuring out how to best exploit them. In many cases, it's algorithm rethinking of our algorithms. I think the hardest part is to figure out how do I change my data structures? How do I rework my algorithms? And so in some cases, it's a wholesale restructure of an application or a software technology. In some cases, it's very surgical for the compute-intensive portions. In the end, implementation, the hard part is rethinking your algorithms, and the implementation of those reworked algorithms often is much easier than the algorithm rethinking. So whether we're looking at accelerators from NVIDIA or AMD or Intel, the programming models won't be as dissimilar as one might think. The real challenge is rethinking your algorithms. And we've been doing that since the start of ECP. So not that we're not going to have some challenges and hurdles, but I do think that these recent announcements have pretty much met with kind of where we thought things were going to go. And so in that sense, I do believe we really are on track relative to our objectives.
So recent comments at some of the conferences are folks in the development community, application development community, who think that this is a pretty big, heavy lift. It's a learning curve that they're going to have to go through with the growing use of accelerators. Is that proper way to frame it, do you think? It
certainly isn't easy, and I don't want to sort of downplay the fact that this is difficult and challenging. I think it requires conceptual, like I said, rethinking of algorithms. Now in ECP, we have a whole spectrum of application and software maturity relative to the accelerators. We have many applications and software technology products that really have already reworked their algorithm design and are achieving fantastic performance on, say, Summit. And so we would anticipate, I think with fairly low risk, that moving that implementation on Summit to Aurora or Frontier may not be seamless, but won't be a heavy lift, so to speak. We have other applications and software technology products that are not quite there yet in terms of rethinking and redesigning their algorithms. And so these comments are, certainly do apply to some aspect of ECP. In terms of, say, our upcoming DOE review, one key aspect of this review is, are we prepared to really help those teams move along more quickly on a more with a sense of urgency? Can we take the successful experiences of some applications and apply those lessons learned and best practices to others? And I think we can. In our three focus areas, software applications and hardware and integration, we have a number of projects that have more or less a direct line of sight to essentially how to really go after exploiting those hardware accelerations. So I feel like in terms of the way we're scoped, we have the efforts in place to help bring along everybody. And the fact that we're a large project with lots of teams allows us to cross-fertilize and share experiences and lessons learned, and that helps reduce risk with regard to moving things along. So I think when you're first exposed to these accelerators, you have to sit back and go, okay, wow, this is a tremendous opportunity, but I've also got to rethink how I've been doing things. In many cases, it's back to the future. Some of the algorithms designed for Cray vector machines in the 70s, 80s now are apropos and work well. on accelerators such as Summit. We have direct evidence that this is not necessarily reinventing or inventing from whole cloth. It might be, sort of accessing an algorithm that was used successfully in the past. Now is again useful now. So
just another tool in the application developer's bag of tricks, huh?
That's right. Indeed, it is, and I think the teams realize that they're not going to succeed on the path that we have by closing their door and trying to do all this on their own. And so we really are managing and tracking and forcing, frankly, integration of efforts, especially the software stack. Key products applications need to not just be aware of, but actually use. And so in many cases, the applications are, to some extent, passing the risk or the challenge of exploiting on-node accelerators to the software technology products, and that makes a lot of sense. And so in many cases as well, they're not doing that, okay, for a good reason. So this is one of the advantages of having a large project where we can plug pieces together to make basically the whole being greater than the sum of the parts.
Got it. Yeah, it makes a lot of sense. So within ECP, I mean, some efforts that I've noticed have been expanding, and some have been more consolidating, some consolidation going on with some of the efforts. Maybe you could give us a few of the current stats to kind of frame, where we are today for the listeners, kind of like ECP by the numbers.
Okay, so we're always not trying, but we always are taking a hard look at how we're organized and trying to see, is there a simpler way to put our organization together in terms of managing. Really, it's not about the boxology so much, because the challenges are always managing at the interfaces, but we have worked hard to consolidate and simplify where possible and where it makes sense. So right now in ECP, we have 81 R&D projects, and that's come down from about 100. Okay, and so where we found areas where we could consolidate, we did that, and it wasn't oil and water. We didn't force it just for the sake of trying to decrease the number. But in many cases, in every case that we've done this, it has helped. So let me give an example. In software technology, led by Mike Aru at Sandia and Jonathan Carter at Berkeley, they recognized that there were several smaller projects, say, looking at I/O, and by putting them together, there were synergies there that we could take advantage of, where they could adopt and use each other's approaches, and we could move toward maybe one API for a particular I/O instance. And so the consolidation wasn't just, hey, let's reduce the number of projects, this is too hard to manage. It was really driven by what makes technical sense. And so right now, I think we're in really good shape to move into our what we call our performance baseline period, which will be this fall and early next year, meaning our current structure of 81 teams, still of order 1,000 researchers across the HPC and computational science community and industry, academia, and DOE labs. But I think this restructuring has us in really good position for the stretch run as we see Aurora and Frontier delivered. So,
you mentioned a few of the folks there, and that kind of leads into what I wanted to get to next. ECP success, in fact, the nation's success with Exascale and bringing it to life, depends on a very, very large group of people, and it's more than just ECP. The collaborating agencies, the collaborating universities, the technical vendor community that ultimately will stand up the systems. So I know it's difficult to single out just a few individuals when there's so many that are making these important contributions, but perhaps you could take a few minutes to acknowledge at least some of the folks, maybe from the leadership team level and so forth, that kind of working behind the scenes a fair amount and don't get the recognition they deserve.
That's a good point. Let me start first with our Department of Energy sponsors. Barb Helen in the Advanced Scientific Computing Research Office in the Office of Science, Tuk Hong in the Advanced Simulation and Computing program in NSA, and Dan Hogue in the Oak Ridge National Lab site office here, who's our federal project director. They have been fantastic in their support, and that doesn't always mean it's a thumbs up team, you guys are doing great. It could mean you guys need to work on this. And so they they give us a good, honest, objective assessment, and they're always there. We speak to them daily, weekly, all the time. So our sponsors have been fantastic in making sure we're on the right course, and giving us the support that we need. Our leadership team, again, consists of about 30 or so, I think 32 by last count, DOE staff across 6 labs, and we've been really fortunate to have leaders in the community with a proven track record and trust and respect of their colleagues. We've been together now as a team for about, for most of the time ECP has been in existence, meaning there hasn't been a lot of turnover. Not that that's bad, but people are all in, they're committed, they have the passion and the energy. Many people, to quote some of our leaders, feel like that my career, this is a culmination of my career. My whole career was built for this. And so, that really helps during, say, tough times where you're trying to prepare for a review, when you realize that this is something that's, that I feel like my whole career was built around. We have people that feel that way. To single out some names, our 3 focus areas: software technology, led by Mike Aru at Sandia National Lab and Jonathan Carter at Lawrence Berkeley, really are up and running on all cylinders. And Mike and Jonathan have made a lot of very productive and useful changes in how things are running and organizing. They worked hard to make sure our software products have a line of sight up into software development kits and are released and deployed on the facilities. Terry Quinn at Lawrence Livermore and Susan Coughlin at Argonne National Lab run our hardware and technology focus area. And both Terry and Susan, I don't know if people appreciate this, are dual-hatted in that Terry is really on point for a large part of the Capitan procurement and deployment at Lawrence Livermore, and Susan for Aurora. And so we're really fortunate to have 2 leaders in the field for procuring, deploying, and operating HP systems, but also leading our staff in terms of what does it take to make sure that products and applications are production quality and get deployed and used on these systems. So, they're able to really, their feet are sort of on both sides of the fence there. And then in the applications area, Andrew Siegel at Argonne and Eric Drager at Livermore lead that area. And they've really taken our applications from what looked like, say, 3 years ago, some interesting, may work sort of R&D efforts, to the applications now have very specific challenge problems. We're assessing them annually. They have very specific metrics, and they're really, for the most part, all on track. And so these folks, it'd be great to bring them back and have them, sort of give their own personal perspective. Have been fantastic in leading these efforts. And I said there are 30, leadership. So Andrew and Eric, for example, have a team of 5 or 6 that each oversee order a half dozen of these R&D projects. But the 81 R&D projects all have principal investigators leading these projects who are, for the most part, senior people with, career track records. And so those folks, and I try to, when I'm talking, and I think our leadership team as well, is to call out these PIs, because that's really where the work is going on. And, we're lucky to have these PIs who are all in, just like the leadership team, to make sure we succeed.
And a lot of the, behind the scenes heavy lifting that takes place is with the project office, which happens to be housed at Oak Ridge. Yes,
and I'm glad you brought that up. This really isn't a customer-client relationship between the PhD scientists and the project office. They really are peers. The PhD scientists responsible for leading the technical areas have learned a lot from the project office about, what does good project management look like? What is our responsibility? How do we need to track cost and schedule performance? It's a tremendous responsibility with the budget we have. And so the project office is in itself a small organization that's made up of people who care about risk, project controls, budget, procurement. All these things are day-to-day sort of contact sports, so to speak, with regard to our technical leaders. So I sit personally at Oak Ridge National Lab, and I think this lab in particular, as many other labs, has a very good track record in project management and leading and executing on large projects. So we're fortunate to have a project office staffed solely here at Oak Ridge that have been through the trenches and running and being part of large projects, know what to expect. This is a unique gig in ECP, but I think we figured out how to really tailor this to formal project management, sort of in and around doing more exploratory high-risk research.
Great. This has been a good update, Doug. I'd like to wrap up with one topic that I know is near and dear to you. Talk a little bit about, if you could, the enduring legacy of the Exascale Computing Project. Very good point.
I wouldn't be here, and I don't think the leadership team or the staff would be here if we didn't think that there was going to be an enduring legacy. The beauty of a 7-year project is it allows you to have a sense of urgency and a sprint, and you pay attention to metrics, and you really make sure you can dot I's and cross T's. But a project would fail if the leave behind wasn't useful. Okay, so let me take you through applications, for example. Enduring legacy there is we're going to have dozens of application technologies that are going to be used to tackle some of the toughest problems in DOE and the nation. And so the applications are now going to be positioned to address their challenge problems and in many cases help solve them or be a part of the solution. So an enduring legacy for us is the applications now are going to be ready at Exascale to tackle currently intractable problems. And when I say tackle, many program offices in DOE, by last count there are 10 of them, and other federal agencies are going to essentially use these as their science and engineering tools. So that's an important legacy. In software technology, I think what we're seeing with the leadership of Mike and Jonathan is the genesis of a probably multi-decade software stack that's going to be used and deployed on many HPC systems well beyond Aurora, Frontier, and El Capitan. And I think by paying attention to what does it take to containerize and package things up and make them production quality and make them basically adhering to application and hardware requirements, we're going to see a software stack that I think DOE will continue to support, maintain, and require on HPC systems of the future. Time will tell post-ECP. Sure. This is certainly, we wouldn't be involved in ECP if we didn't expect and frankly require our efforts to really have a line of sight beyond 2023.
Great. That's all I have. Is there anything else that you'd like to throw out there for the community at this point in time?
Just that we appreciate the support, the engagement of the HPC and R&D and computational science community. I'm not going to claim that we always have all the answers, so we encourage the community to feel free to touch base with us, myself personally, the leadership team. There are ways you can collaborate and work with us. There are certainly ways that you can engage and help us move forward. So we're really lucky to be a part of this big project, but always happy to hear about new suggestions, new possibilities from the community writ large.
Awesome. Okay. Well, that's a wrap on another episode of Let's Talk Exascale. We've been talking with ECP Director Doug Kothe for the Exascale Computing Project. I'm Mike Bernhardt.